So let me give you an example. What would be an example of nonlinear problem? Well, it would be solve an equation. X cubed minus 3x plus 5 equals 0. Solving that equation is not a linear problem because the equation is not linear. Right? Now, where is calculus coming to help us? Well, it comes in this case in the form of Newton's method. That's something you may or may not have studied, but there is such a thing as Newton's method. And what is that about? Well, it is about making a guess. What you want to find is you want to find the number x such that this number substituted into left-hand side makes it 0. So make a guess. Well, let's call it x0. The first guess. And you may have guessed it right, if you're lucky, but probably not. And then, if this is not the number making the whole thing 0, what can we do? Well, what we can do is we can look at the graph of this function. So the function is going to be y equals the left-hand side, x cubed minus 3x plus 5. Well, suppose that is the graph of it, or at least a part of it. You're looking for that value on x-axis, and suppose your guess was not correct, and you found some x0. And then what we can do is we can look at that point on the graph, and we can zoom in to that graph at that point, and we can realize, well, that graph looks like a line, and we can replace the whole graph with a line, extend the line, and make our next guess by saying that that value, x1, is our better guess about the solution. So how do we do it algebraically? Well, algebraically you write down the equation of tangent line. Right? How do you do that? Well, you know this point on the plane, that is x0, comma, let's call this f of x, a function of x, comma, f of x0. And also you know the slope of tangent line, that's the derivative at x0. And then you say that y minus f of x0 divided by x minus x0 has to be exactly the slope, which is f prime of x0. And then if you solve for y, you find y equals f of x0 plus f prime of x0 times x minus x0. Right, so that's the equation of the tangent line. And you can find where the tangent line intersects the x-axis very easily, because you can do what? You can equate that to 0, solve for x. And what kind of problem is that? Equating this number plus another number times x minus x0 to 0 and solving for x. That's a linear problem. Right? That's a linear equation, a linear problem. So you reduce nonlinear problem, essentially any nonlinear problem, right? For any equation, you can make a function, you can differentiate that function, you can find that linear equation, and you solve this linear problem, you find that point, and you hope that this point is better than x0. And then, if it's not good enough, well, you repeat. And you see that after the second step, I'm very, very close to the actual intersection. And the next step, I mean, the tangent line is so close that I will not even distinguish the actual solution from the approximation with the thickness of my marker. Right? So the process converges to the solution very quickly. So that's what essentially calculus is about. It's about reducing nonlinear problems to linear problems.